Hello guys, welcome back to my YouTube channel. My name is Mike Matthew KE, and this is going to be a new series on development of chess. So basically you're going to be building a chess game from scratch using Python, and we're going to go through how we're going to develop the structure of the game. You're also going to put in the visuals, obviously, that's very important. And then at the end of it, we're also going to look into how we can create an AI for this game so that you can also play against the computer instead of playing one versus one person, right? So, to start off, we are going to set up our project. To start off, I'm just going to create a new folder called chess. And then we can open Visual Studio Code in this directory. Open with code. Great. So the first thing that I usually like to do is to set up all the external libraries I'll be using. And one of them is going to be Arcade. So basically what Arcade is a library that allows us to that has basically laid out everything for us. So we'll be able to create a window with it. We'll be able to render to that window with it. And even to add some things such as sprites, which we'll come to learn what they are later on. Even if we need to add, let's say, audio, this has basically made the building blocks for us, and so it will be easier to start off. So I'll start off with a template that they already have. So to get this template, you just have to go to getting started, examples, then starting examples. And then here we'll have a starting template using window class, right? So that's what we'll use for today. So I'll just copy this and then we'll transfer it to our main. Right, I should have first actually, I'll just make sure we have an environment first, a Python environment. That way, when you're building our code, we'll not be putting all our extra libraries in the whole global scope. That is right. So I'm just going to refresh that window so that it uses the new stuff. Okay, so here we go. So pip install -r requirements.txt. This will install all the requirements that are in this requirements.txt, right? Then we can create our main.py, which will basically be our main game. So I'm just going to copy everything from here, and that's what we'll put right here. And this is how we'll start our development. Right, so I've noticed here that I've right, let me relaunch this terminal. So I actually just still running on the global scope, so let me just run pip install -r requirements one more time, the txt. Right, okay, so that's good. So next thing we'll do, so basically what this has done for us, you can see that the starting template, once you learn the classes, you can begin. Basically, it has laid out for us. You can see we have our window width and our window height. We have our starting template as our window title. So I'm just going to modify this to begin with. So I'll just make the window title chess. Since we are doing chess, maybe I can make it an 800 by 800 window. Alright, so that is just square like our game. So there are all these function definitions. We'll come to be looking at how we're going to be handling those later on. And yeah, so we can just see what that looks like when we run. No module named Arcade. Interesting. Okay, so I've resolved the issue. So basically what was happening is I had multiple versions installed, and because I was doing a test, the last version I installed was actually 3.11. So now I've just removed Python 3.11 and also ensured that Python 3.13 is available on the environment variables. So now if I do this Python version, we can see that now we have Python 3.15. That also means I'll have to recreate my environment. So I'll just delete this venv file and redo that process again. So Python -v, -m, then venv, venv. So that creates a whole new environment for us. Great, it's done. Then I'll reload the terminal with the cmd, and then now I'll install the requirements again. Python -r, pip install -r requirements.txt. Great, so now that it's downloading, means we're good to go. All right, so I'll just wait for that to finish. So as that is happening, yeah, so it's completed. So now if I run this now, you can see we get a window with the title chess, and this is our 800 by 800 size that we defined, right? So what I'm going to do next is, since we're doing a project setup for today, I'm going to define how we're going to be dealing with our chess pieces, right? So I'm just going to create pieces.py. Basically, this will represent the whole of our pieces, what we'll be doing with them. So the first thing is how we're going to be recording the movement, right? If you look at chess, we usually have different pieces. For example, the rook can only move horizontally or vertically. We have the bishop who can only move diagonally. We only have, let's say we have the queen who can move in any direction, any number of times. So it's not just a matter of which direction the piece can move. It's also a matter of how many steps that piece can move. And so the question is, how can we present that in our code? So let's say, for example, you want to, actually, I think the best way to illustrate this will be with an actual chessboard. So I'll just open chess.com right here and say play with computer, right? So here we have, so let's say we want to present the movement of, let's say this pawn, for example. So you can see we have the movement. It's either going vertically, so that's vertically. So this is a pawn that can move vertically, right? And then if we have a bishop, for example, it can only move diagonally. So basically everything is on a 2D plane, and we can represent that movement as, let's say I can only move, let's say that if I can only move diagonally, then that means the only type of movement I can make is, let's say, 1-1, right? For example, that 1-1 would be represented as I have moved one position vertically and one position horizontally, and that makes this queen move to that position. So basically, we can represent each movement as a tuple, right? Basically representing how many times you can move in a, or rather, what kind of direction you can take. The other thing now we can add to that is how many movements you are making, right? So for example, if it's this queen, so there's 1-1, or if we multiply, let's say we multiply that by 3, then that means it can be 3-3. So that becomes the movement that player has made, right? And I'm definitely being schooled by a computer here, but that was not the focus. So when we come back to our code, how we can represent that player movement is by having a tuple, right? So I'll just put it as a class called player movement, and it will take an integer x and an integer y. Right, sorry, I'm still coding in C++ in my mind. So y integer, right? We might change this configuration a little bit later. right? Or rather, yes, we'll just maintain that. Then the next thing now is the scale, right? So the scale, uh, let's say as an integer as well. So basically, if you're moving, let's say, if let's say it's this bishop moving, so if it's this three movements, right? And then since we are representing that this player has moved backwards, we can also present it as a negative. So we multiply it by a negative number. So that would be that movement that we just made will be a -3, right? So that's what we can do with the scale. Now, something interesting that we have here is we have an interesting player here called Knight. So a knight has a very interesting type of movement, which we can represent. We can represent it as, let's say, for example, if it's this move, let's say the knight has moved one position to the right and then two positions upwards or forward. So that means we have, if you're using X and Y, then you'll use 1 and 2 to represent that movement that we've just done, right? This is already a checkmate. Well, great. So now that means this can represent that. But then what happens to scale? For a knight, for example, the scale will only be 1. We can never go past that scale, right? Which means each player has a magnitude at which the scale can be done, right? So this scale, I'll just put it as a max scale, right? So that we can represent whenever we're moving, this is the farthest that you can move in a certain configuration, right? Right. So for now, I'll just leave it as scale. So I've seen how we can try to place this in terms of our movement. Now, the other interesting player that we also have, let me just reset this game. How do you reset it? Oh, I was not trying to log in. So let me just resign and rematch. So another interesting player that we have is this pawn. So when the pawn moves, if the pawn is trying to, let's say, take another piece, the movement of that pawn is diagonal. It's no longer moving forward, right? So that's also another interesting type of movement that we can have, right? So how we can represent these movements, right? So we can have the movement and the max scale, like I put it before, max scale, right? And then whenever we are looking at, let's say we have our piece. So let's say we have a class that represents each piece, right? So if we have a piece here, what we can do is we can have an array of all possible player movements that we can have, right? So for example, if you're doing, let's say, if you have a movement for if you're doing for our bishop, right? So the only possible movements that our bishop can have, right? So possible moves, only possible movement that you can have. This should be a list of player movements, right? That is small. So the only possible moves that you can have here are is just the one, a player movement where we have one x equals 1, y equals 1, and max scale here. So max scale will be how many times can the player move, and since the bishop does not have a maximum limit of movements, So if, for example, this bishop is at this position where this rook is, that means the bishop can move eight times. When you're looking at, if that bishop is here, then we can have 1-1, right? But 8 times. So that means he'll go all to the position, all the way to this position right there, right? So max scale will be 8, and that's how we represent our player movement, right? But now, if you are representing this player movement, then we need to modify this right here so that it's an actual class that takes in the x, which is an int, y, which is an int, and the max scale, which is also an integer. Let's not forget that we also have to have self, since this is a class. Then we'll assign self.x to x, self.y to y, and then self.maxScale to max scale, right? So now every piece has the possible moves that they can play. So I'll also put this in an init function, right? Then we say self.init, self.possible moves is equals to that. So this is if, for example, you're referring to our bishop, right? So that's how we're representing the movement of the bishop. Basically, the bishop can move in this direction at any scale. Now, something interesting that is here as well. What happens, for example, if let's say this bishop is here, right? Oops, the bishop has been taken. Let me move this other one. So let's say this bishop is at this position, right? So we have 1-1, right? And we can scale that by 8. But now, what if we want to move in the opposite direction, right? So now we have, we are scaling it by, so we have 1 and -1, right? So that means this, these values can still be negated, right? The scale remains the same, yes, but the kind of movement we can make is still being, we can still be able to negate it. So in these possible moves, the question will be, should we maintain just this as a possible move, just one of it, or should we be able to account for any type of change in direction? Because now 1-1 represents only one direction, right? So how we can represent that now is we can have all possible directions that the bishop can take as possible moves. And now that becomes a list here. Actually, originally we did not put it correctly, but if we put it as a list, so I'll just duplicate this 4 times so that we have 4 instances. So we have 1-1, we have 1, -1, we have -1, -1, and we have -1, 1, right? So those are the possible moves that you can have. So 1-1 being this movement, this position, 1, -1 being the other way. Then we have -1, -1 being obviously the opposite of this, and then -1. This will be -1, 1. No, that would be, well, one of them. We shouldn't really look so much into that, but basically it's just that movement that you're trying to represent as a tuple, right? So we have our tuple represented there. Now, actually, this might actually make it a bit easier if we put this as a tuple, self.direction, and we place it as x and y, like so. And then now we have scale, right? So that means when you're trying to represent, for example, let's say we have a class of, let's say the pawn, right? if you have the class for the pawn, then we'll have the possible moves. Just copy this and modify. So possible moves for the pawn is just moving forward. It can only move forward, or when taking another piece, it can only do it diagonally, right? So that means we can do so if it's moving forward, that means 1, moving in 1, sorry, 0, 0, since x will never ever 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 it will never ever move sideways, but it can move forward. That will be x and y equals 1, and the max scale is 1, right? Also, we can have the other movement that we have is a 1. So movement in 1, and then we have, so 1 1 whenever it's taking a piece to its right, and then negative 1 1 whenever it's taking a piece to its left, and that leaves that. So all its movements is only one step, except now remember, whenever we are starting as well, the pawn can also move 2 steps, right? So now that makes it a little bit tricky, because now we have this, but now the max scale is no longer 1, it's 2 whenever you're starting out, right? So when it comes to this, I think what we can do is we can decide to change it up. So we can try to make this a little bit more, let's say, a little bit more fluid. So how we can make it fluid is we can put it in such a way that we can later come in and be able to modify this scale, right? So we can create a function here to modify the scale of our player movement. So modify scale, or let me call it change scale, so that it's very obvious what we are doing. Self, and then we change the max scale here, which is an integer, and all it does is just changes our max scale. So another way, I think we can also try to compress this, right? So we can have no, actually, let's reserve that. Let's try and look at the rook, right? So the rook moves, we have 2 1 or 1 2. So the possible moves for a rook, if we can try to place that. So when we initialize the rook, what we have is possible moves, and the moves we have are, so the rook can either, let me just place this one here. So this movement is 1 going forward, that's 1 on y, and then -2 on x, right? So we have 1 on y and -2. We also have 2 on y and -1, right? For x, that's 2 on y. Then we have on this other end, we also have this movement. So we have 2 on y and 1 on x. Right, 2 on y and 1 on x. And then, so if I move this knight here, for example, it will allow us to also look at all the possible moves. We also have 1 on y and 2 on x, right? So 2 and 1. If I copy this, this should actually be the same as queen, right? Since the scale is 8, and then for the king, we'll just make sure our scale has gone back to 1, since the king can only move 1 step at a time. You cannot skip boxes, right? All right, so now we've been able to represent all the player movements possible for any kind of player. So now there's now a bit of an issue, let's say for our pawn, since the pawn has a kind of unique movement whenever it comes to um, basically we have special moves. That's basically what you're saying. We have a special moves that only take place at a certain point, and being able to do these special moves really changes how we can approach things, right? So the question is, how do we represent these special moves? Because now we have a pawn who can take another piece by moving diagonally, right? So here we're representing the movement of a pawn as a general movement, but it can't take place every time. At least for the first movement that we have here, we already have a mechanism, like when the pawn moves the first time, the pawn um, can no longer make a different movement, right? So now we have special movements that we also need to be able to represent. Well, when it comes to this, we can try to represent it as a boolean, right? This is a move that is possible at the moment, right? Or is not possible. So basically, whenever we're doing this, we can also have a move that we can activate, right? Basically, it's a move that it's basically saying that we can be able to perform this move at the current moment, right? So how we can do that, we can just have a boolean. By default, we can just put it as true, so that we have our an active type of movement. Basically, it can be done. That's what it means by active. And oh, we just realized we didn't complete this function here. Now, so when we do that, now we have moves that we can be able to do, but they are not active by default. Well, at least for our pawn, this movement, the moving to positions that we start with, is active for every pawn whenever we are starting out, right? And if that is an active move, then that's okay. But then once that pawn has moved, for example, like this one, we cannot move the two positions anymore. That means we need to change that. We need to be able to change this type of special movement from active to inactive, and that means we just need to have deactivate movement right. So if it's deactivating a movement, so you just put active to false. And if we are activating a movement, so we move active to true, right? So basically we have all the data now that we need to represent any type of movement. So later on we'll come into seeing how we'll implement this these special moves. However, for the king, I'll just make sure we add no, all moves are covered here. So we'll always need to be able to represent these movements in a way that you can manipulate them, right? So in this case, when it comes to the king, where's the king? So the king, we have this this movement for castling, right? Which means the king can now move two positions. But now, when it comes to the king, we only have these movements that are one position at a time. So if you're trying to represent that movement of the castling, so we can represent it as the movement where we have x equals 1, y equals 0, but then the max scale is 2, right? Actually, that it's actually 3 when you're starting out. 3 because we have we also have castling on the left side where if you have this rook and this king, they can castle and the king will move 3 steps rather than 2, right? So we have this, and how we can represent this as well, we can see that this is not an active move. So we make sure that it is not active simply because when we start, the movement is blocked. So basically we cannot do that movement at all, right? Right, sorry, I forgot something simple here. So x1, that means we're going right. So that means this will be scaling 2, and then we have, for going left, we have -1, right? Which now has the possibility for doing 3 times. And now we've been able to represent the castling movement of the king as well. So so the other one we can modify here is the pawn movement, where these diagonal movements are false whenever we start off, right? Right, we need to represent it. Active equals false for pawn whenever it comes to taking another piece, right? And later we can be modifying this as we go. So basically that is covering the movement of our queen. We've not set up our board yet. We've not set up all our pieces now visually, but we already have our representation for movement. Maybe what we can also add as the last thing, we can also add our representation for the board. So I'll make this a class, and how we'll represent it is, how we'll represent our board is we'll have our board as basically an 8x8 matrix, right? Or an 8x8 list within a list, right? So self.board will be so I'll initialize this as a list of none. I'll just write it all out so that we have a bit of a visual look at how we're representing our entire board. Right, and then 1, 2, 3, 4, 5, 6, 7. So we have 1, 2, 3, 4, 5, 6, 7, 8. I just split it down the middle so it's easy to count, and then I'll also tab this just for visibility purposes so that you're able to see the entire representation of the board. And so this is basically how we're representing our entire board, right? This is where we'll end for today. We've done a simple setup for our pieces, how the pieces will move, representation for their movement, as well as the board itself, right? So now, when we come next time, we'll be able to look at making sure that we are able to represent these pieces on our board as they are. So I hope you've enjoyed this lesson. Next time we'll be looking at how we can represent everything on the board, right? Every piece that we've created, every piece that we represented, how can we represent it on our board, as well as how can we actually visualize our entire chessboard, right? So we'll actually start the visualization. We'll just create the grid first of all, and then we can also see how we can render those pieces so that we'll also be able to see all the pieces represented on our board. So I hope you learned something, and I hope you're excited for next time. See you then.